buffers. Do you know what a buffer is? I think you do.
I think I do. I think I got a brief explanation of what they are.
All right. So it's pretty much when you have a solution which the pH won't change even though you're adding acids or bases to it. Yeah? So your blood is a buffer.
Yep.
This is important to know. These are how you work out buffers. So here's an example firstly of a wordy buffer, and then we'll look at the math part of it. So acetic acid is an example also of a buffer because, let me see. Do you want me to write it down? Would it be easier?
So buffers used, what is used to change the solution, the solution's pH.
So can you see my whiteboard?
Yeah.
Cool. I'll write it down. So buffers. The idea behind a buffer is that it is a solution that, oh God, that can resist change in pH when adding small amounts of acid or base. That's your definition. If you ever get asked in an exam, that's what I would write. Heath?
So they resist the change of an acid of the pH. The change
Heath,
of
are you there?
pH, sorry.
Oh, okay.
Yeah, they so
Okay.
they can resist the change of the pH. Is that what they do?
Yeah. So I'll go through an example to make it logically. All right. You know acetic acid?
Yeah.
Oh. You're going to put it into water. And this is an equilibrium sign, by the way. It's not a straight chain. What you're going to do is you're going to get CH3COO minus.
Okay.
And you're going to get a hydrogen ion. Does that make sense?
Yeah.
All right. So the idea of a buffer is you need a salt. And a salt for this situation would be this one. Do you know what that is?
So it's your salt. So your buffer is the salt, is it?
No, you're adding salt to the buffer.
Oh, okay.
Because you're going to get two products from that salt. You're going to get sodium ions, which you don't really care about, and you're also going to get the CH3COO minus.
Okay.
All right, let me explain that to you. Let's backtrack for a second. Do you agree with me when something is at equilibrium, especially things such as weak acids, they usually don't go far in the equilibrium. They're usually right here. Does that make sense? They don't dissociate as much. Do you agree with me?
No, yeah, they don't.
They don't dissociate. So example, they're just going to stand like here. So you're going to have a lot of acid, a lot of water, but you're not going to have many products. You're not going to have a lot of hydrogen ions, and you're not going to have a lot of CH3COO minus ions. Does that make sense?
Okay, yeah.
A lot of, all right, I'm going to just write here. So, a lot of reactants and little no products. Yeah? Make sense? So what happens is when you add that small amount of salt, so the idea behind it can be any salt. The only rule about it is that your anion, so the CH3COO minus, has to be the exact same of the product. Can you see that these are the same?
Yeah.
Perfect. So when you add that salt into your buffer, what happens is you're allowing for more product to be in the system.
Yep.
You're giving more products. And so when you're going to add acids and bases to it, let's say I'm going to add a bit of hydrogen ions, right, into this equation here, this buffer, what's going to happen is because you've added more salt, you're going to have the CH3COO minus ion combining with the hydrochloric acid, right? And it's going to form, you see what I'm typing down here?
Yeah.
It's going to form NaCl plus CH3COOH, which is the acid. So you haven't changed anything. That's why the pH doesn't change it. You're just going back to the reactant.
So
And
if you add, so they can, so no matter what you do, no matter what acid or base you add to your, so you have an acid, you add some base to it, or add some more acid, its products will make the reactants again, basically, so that the pH remains the same.
Yep. So basically, so if you put HCl or an acid into it, the salt, the most important part for you to understand is this salt, like the anion of the salt is the most important. Can you see that because you've got more product now, because of the salt, it's going to combine with the hydrogen ion of the acid and it's going to reform the acid itself.
Okay. Will this always happen? So if you add more acid of any sort to that, it'll just take up the hydrogen. It's going to take the hydrogen ion from whatever acid you add to it, and it'll
go back to
itself.
So it's going to go back to the reactant. So the equilibrium will shift back to the left.
Okay, that's cool.
Base, you've got sodium hydroxide, yeah? Let's, for example, so you have an OH situation. So what's going to happen is this hydrogen ion that you've got right here in the equilibrium, it's going to combine with it, and it's going to go, it's going to form water, which is, again, it's neutral. So it's just moving the equilibrium back to the reactant.
So you can add bases too, but they'll form water.
Yeah.
Basically.
Correct.
Okay. All right. Okay, that makes sense.
So that's pretty much the mechanisms of acids and bases. The other thing that I can say is with bases, you can have one more fancy thing happen.
So only certain acids and certain bases are considered buffers, isn't that right?
Well, usually weak acids are
Is that because they only have one hydrogen to give off, so it's easier for them to go back?
No. It's because, remember, weak acids they reach equilibrium. Strong acids they don't have a problem with dissociating. They fully dissociate. There's no point of putting it into a buffer.
Okay. Yep.
So the last thing I just wanted to say is to do with bases. The other idea that can happen is that your acid, if let's say we run out of this hydrogen ion that you have in your products, right? Let's say we run out, we've used it all up. The other way a buffer can work with it is it can combine with the acid itself. And we've got heaps of acids. Remember, we've got so much of it in our reactants. We haven't used much. It hasn't dissociated. So you're going to have hydroxide combining with the acid itself. And what's going to happen is, again, you're going to form H2O and you're going to form CH3COO minus. Again, nothing, the pH isn't going to change because you're not forming any new products. It's just shifting the equilibrium a bit to the right now because you're forming more of the CH3COO minus.
And then so no matter what you add to it, it'll always return to that pH. So okay. In whatever method.
Yeah.
Okay, I get that. That makes sense.
That's everything pretty much you need to know about buffers.
Okay, so it's basically, there's not, is there like calculations to do this, or is it mainly based on equations?
I don't know how far your teacher has gotten.
Well, we haven't started it yet, so.
Oh, okay. Well, yes, there are questions that are going to be like this, which is just theory, where you're going to be explaining, what happens if you add more acid to it, and you can say, well, it combines with this. And second part of that syllabus is where you will be doing calculations.
Okay. So okay. So this is sort of, I can think of these as, this is buffers to act similarly to just as equilibriums do.
Yep.
They return to the baseline or whatever it is, um the yeah, okay, so they okay, I think I get it. I get it. I get it.
Yep. So there are questions to do where the only type of question you can be asked is to work out the pH of a buffer, which is again using the ice table, using torque, which is products over reactants, and etc.
Okay, so that's okay. So it's more theory, and also there's the same sort of working out for
Mm-hmm.
these sort of questions as well. All
Mm-hmm.
right.